In this session of physics, we're going to talk about units and measurements. But to explain units and measurement fully, we're going to solve tutorial sheet 1 on units and measurements. So these are some of the questions that we're going to solve, 1 up to like 8 or so. So without wasting much of the time, let's start with the first one. So the first one is asking us to convert microliters to millimeter cubed, and the rest follows. So let's start with the first question. A is saying microliters to millimeter cubed. So you know that 1 microliter is just equivalent to 1 millimeter cubed. So this is a conversion unit, so there is nothing much to solve about question 1. Let's go to question B. Now B, we are asked to convert 4.5 times 10 to the power 3 kilogram per meter cubed to grams per, we're converting to grams per centimeter cubed. So how are we going to achieve that? Okay, so allow me to write it on top, grams per centimeter cubed, because that's where I want to go. So for us to convert our, to convert our kg, you just know that 1 kg is equals to 1000 grams multiplied by, now for us to convert our millimeter cubed to centimeter cubed. Okay, so how are we going to do that? Allow me to just write the conversion units down here. You know that 1 meter is just equals to 100 centimeters. Now if 1 meter is equals to 100 centimeters, so if what if we cube it? 1 meter cubed, it will mean we multiply 100 by 100, right? Which should give us 10,000 centimeter cubed, centimeter squared actually. Okay, not really 1 meter cubed, but I meant 1 meter squared. That will mean like you're multiplying 100 twice, right? So it will be 100 and another 100. You are saying centimeter cubed, centimeter squared. Okay, now what if now you have 1 meter cubed? That will mean you are multiplying 100 3 times. Okay, so if you're multiplying 100 3 times, you're going to have 1 and 6 zeros, centimeter cubed. So 1 millimeter cubed is equivalent to 1 million centimeter cubed. So that's a conversion unit that we're going to use to solve on the other side. So allow me to just write it. We're saying 1 meter cubed is just the same as 1 million centimeter cubed. Now that we've got this, we've got everything that we need to solve our question. So now we can cancel the kg, and the kg can divide. The meter cubed and the meter cubed can also divide. Okay, so now what do we remain with? Allow me to cancel some of the zeros. So I can cancel these 3 zeros and these 3 zeros. Okay, therefore what I remain with, is what now? So allow me to also convert this 4.5. Because it's multiplying by 3 zeros, it means the point is going to move 1 2 3. So therefore when I do that, I'm just going to have 4,500 grams on top, because I've remained with this gram, divided by, I've got a 1000 down, 1000, then there's a centimeter cubed, don't forget. Then now that we've got this, we can divide. So the 2 zeros can divide, or I can cancel the 2 zeros. Then 45 divided by 10, that will just give me 4.5. Now it's grams per centimeter cubed. and we have converted to that units. So now let's solve C. C, we are asked to convert 40.0 microliters to liters. Okay, so how are we going to do that? Now, you know that the conversion unit is 1 microliter is just equals to 10. You know that micro means 10 to the power negative 6, right? So according to your prefixes, so 10 to the power negative 6 liters. So this is a conversion unit. Then we are asked to convert 40 microliters to, let's say, to liters. Let's put this as x. Okay, now if we were to multiply, like we cross multiply like that, what are we going to get? If we cross multiply, I'm going to have x microliters is equals to, then when I multiply 40 by this, I'm just going to have my 40 microliters multiplied by 10 to the power negative 6 liters. Okay, now because I want to find my x, I'm going to divide by microliters on both sides, Okay, therefore this would cancel. I'm just going to remain with x is equals to, now your microliter and your microliter can go. So this means you're multiplying 40 divided by 10 to the power negative 6, and you know that it's just going to move one step ahead. The 0 is going to go, so you're going to have 4, let's say 0.0 times 10 to the power, instead of negative 6, now we have negative 5 liters. So this will be your final answer. Okay, let's solve another one. So we're going to D. Now your D is saying we're converting 40, is it 400? Yeah, 400 deciliters to liters. Okay, so what are you going to do? You know that this is just the same as 10 to the power, is it negative 10? 10 to the power negative 1, right? So it means 1 deciliter will be equals to, how can we convert that to be 0.01 liters? Okay, so now we're trying to convert 400 deciliters to liters. Let's say now this is x, so we're going to do the same. We're going to cross multiply. So x multiplied by 1 deciliter is equals to 400 deciliters multiplied by 0.01 liters. Allow me to divide by 1 deciliter on both sides, 1 deciliter on both sides. Okay, so now therefore our x is going to be, the deciliter and the deciliter can divide, therefore 400 multiplied by 0.01 liters is just going to give us a 40 liters. So that's why we're going to convert that one. Then let's solve E. Now E, we are told to convert 0.04 milliliters to gigaliters. Okay, now what are the conversion units? Okay, so the conversion units, you know that 1 milliliter is just equals to, I think this was part of like the first question I was solving. So 1 milliliter is just equals to 10 to the power negative 6 liters. Then what about 1 gigaliter? What about in terms of liters? 1 liters. 1 gigaliter. Giga means 10 to the power 10 to the power 9. So it's 10 to the power 9 liters. Okay, so now we are taught to convert 0.04 milliliters to liters, to gigaliters actually. So let's say this is x gigaliters. So how are we now going to do that? So therefore our conversion unit, it will be just simple. So it will be 1 milliliter is equals to, allow me just write it here, 1 milliliter will just be equals to 1 times 10 to the power negative 12 gigaliters. Okay, so that will be our conversion unit. Why? Okay, because of that. So 10 to the power negative 12. Then what do we have? Because a milli, it will give us something like a negative 3. A giga, it will give us like a 9. And when those add and plus there's a negative 6 here, they just give you a negative 12. So now what do we have? This will just now convert to, let's put now our x, because our x now will be equals to how many gigaliters? 0.04 times this conversion unit, which is 10 to the power negative 12 gigaliters. Okay, now when we multiply this, we'll just get 4 times 10 to the power negative 14. So that will be our final answer for this question. Let's solve the second question. Now we are told to suppose, okay, there is a supposition here. Suppose hair grows at a rate of 0.79375 millimeters per day. Find the rate at which it grows in nanometers per second. So nanometers per second. Because the distance between atoms in a molecule is on the order of 0.1 nanometers. Your answer suggests how rapidly atoms are assembled in this protein synthesis. So we're trying to find, they've told us to find the rate at which it grows in nanometers. Okay, now what are we going to do for this one? So we've been given a conversion unit. We are saying this hair grows at the rate of 0.79375 nano, or it's millimeters per day. Okay, now we're trying to convert this to nanometers. Is it per second? Per second. So it means we're supposed to convert our millimeters on top to nanometers. Then we're supposed to convert our days to seconds. So let's just do that. So how are we going to? Let's start first with our millimeters. So you know that 1 millimeter is just equals to, because we're talking about nanometers, we solved this one early, so it's just going to give you 1 million nanometers. Okay, now want to convert this, the 0.7 that number to nanometers. So it means we're just multiplying 1 million, so we're multiplying 0.79375 multiplied by 1 million to convert it to nanometers. Okay, so what are we going to do? We're going to now have, when we multiply that, on my end I'm getting 793,750. This is nanometers. Don't forget there's a day here, there's per day, so write your per day. Per day. So this is in days. Now let's convert also the days to seconds. Okay, so now what do we do? Allow me to rub on top. Now you know that one day or 1 days 1 day is equals to 24 hours. Okay, you know that now in terms of hours, 1 hour is just equals to 60 minutes. Okay, then 1 minute, you know that it's just equals to 60 seconds. Okay, now what about 1 day? Now in terms of seconds. So in terms of seconds, 1 day will be, you're going to multiply your 24 multiplied by 60 multiplied by 60. Therefore you're going to get now your seconds. So when we multiply that, on my end, when I multiply, I'm getting 86400 seconds. Okay, so this is in terms of seconds. So what that means is that now we've converted our day to seconds. So I'm going to wrap this day and put seconds. In terms of seconds, what is it going to be? It's going to be 86400 seconds. So now these two can divide. When they divide, what am I going to get? So on my end, when I divide, I'm getting the final answer to be 9.19 nanometers per seconds. So this just tells you that hair grows at a faster rate in your body to be replaced over and over like that. Okay, so let's solve the third question. We're saying the traffic light turns green and the driver of a high performance car slams the accelerator to the floor. The accelerometer registers 22 meters per square seconds. Convert this reading to kilometers per minute squared. Okay, so what are we going to do now? You know that your 1 kilometer, in terms of kilometers, because kilo means 1,000, right? So 1 kilometer is just the same as 1,000 meters. Okay, then we also start to convert our seconds to minutes. Okay, now these ones are squared. Okay, but let's just write the general conversion unit. We say 1 minute, we're just talking about this. 1 minute is just equals to 60 seconds. Okay, now that you've got this, let's now solve. We're saying we're converting to 22 meters per square seconds, so multiplied by, now we're going to say 60 seconds, but now we are going to square 60 because it's squared, right? So let me square like that, divided by 1 minute. I'm also going to square the minute like that, multiplied by. Okay, then what are we going to have? Now we know that 1 kilometer, we're just writing that conversion unit, 1 kilometer is just equals to 1,000 meters. Okay, we have everything that we need. So what are we supposed to do? What we're just supposed to do is just to cancel. So the meter and the meter will go. Which other conversion between second and second will go? Okay, so now that we've got that, we've squared 60 because you know that 1 meter is equals to 1 minute is equals to 60 seconds. But now this is minute squared, so we have to square it. Okay, so that's why I've squared the 60 as well. So now that we have that, what are we now going to have? Okay, so when we solve that, let me just punch everything together. So I'm finding 79.2. I have a kilometer on top, so that is kilometers per, there's a minute squared, so I'm going to write minute squared. We would have now converted to the units that they want. Okay, now let's solve question number 4. Now question number 4 is saying an ampule contains a solution of drug of 150 micrograms. So we're saying 150 micrograms per 2.5 mils or milliliters. Convert this dose into grams per liter. So grams per liter. So now you're able to see that want to convert our micrograms to grams, then want to convert our milliliters to liters. Okay, nothing complicated here. So allow me to just write everything in advance. So we are converting 150 micrograms to, okay, this is divided by 2.5 mils. Okay, multiplied by. So what will be our conversion factor? You know that 1 milliliter, milli just means 10 to the power negative 3, right? So it's 10 to the power negative 3. We have a liter here, so I'm going to write it liter. Okay, that is the conversion unit. We'll come to the other side. Now you know that here we have a microgram, okay, because we also want it to go 1 microgram. Micro, you know that just means 10 to the power negative 6, right? So I'm going to write 10 to the power negative 6 grams. Okay, now that we've got that, all we just need is now to start cancelling. The microgram and the microgram, they are going to go, okay, they are going to divide. Then the milliliter and the milliliter will divide. Then we have everything that we need. Okay, on top, if I multiply 150 multiplied by 10 to the power negative 6, I'm finding 1.5 times 10 to the power negative 4. There is grams, okay, divided by, when I come down, I've got 10 to the power negative 3 liters multiplied by 2.5. So when I multiply that, I'm going to have 2.5 times 10 to the power negative 3 liters. Okay, let me just write it like that. Then when I punch this, I'm finding 0.06. We've got our grams on top divided by our liters. So it is 0.06 grams per liter. Okay, let's solve question number 5. We're saying the skin is the largest organ in the human body. For a human adult, the average area of the skin surface is about 1.80 square meters. How much square foot is this area? Okay, how much square foot is this area? Okay, so we are told is the skin surface is about 1.8 square meters. How much square foot is this area? Okay, so they've given us the average area of the skin surface, which is that. Now you know that in terms of meters, a human being, 1 meter squared, in terms of feet, how tall on average, you can say maybe it's just about 10.7, let's say 764, okay, feet squared. That's the conversion unit. Okay, how tall in terms of average. Now we're saying the skin of this person, let's say like they've given us, is that 1.8 meters squared. Okay, so we're just multiplying this in terms, because we want to convert it to feet squared. We're going to get our conversion unit, which is, we're saying 1 meter squared is just equivalent to 10.764 feet squared. Okay, so this and this would divide, and when we multiply that, it's just going to give me 9.39 feet squared. So this is how you're going to convert it based on the knowledge that you have about the average height of a human being. Question number 6, we are saying if the density of carbon tetrachloride, okay, is 0.793 grams per milliliters, and the sample has a volume of 9.29 milliliters, what is its mass? Okay, I think this is very simple. So they've given us density is equals to mass over volume, right? We are asked to find the mass. Okay, how are we going to find the mass? We're just going to cross multiply, right? So when we cross multiply, our mass will be equals to density times volume, right? Now we've been given a density of 0.793 grams, let's say per mil, multiplied by the volume. The volume they've given us is 9.29 milliliters. Okay, so what are we going to have as our mass? So the milliliters and the milliliters are going to divide, and when we multiply what is on top, on my end I'm getting the mass to be 7.36 grams. You're done. Let's go to question number 7. So we're saying table salt has a density of 2.16 grams per ml. If you use 2 mils on your food, how much in milligrams is that? Okay, so how much in mils, how much in milligrams is that? So we've been given the density 2.16 grams per ml. We've been given the volume is 2 mils. Okay, then they want they want us to find how much in milligrams is that. So we're trying to milligrams is mass, right? So we're trying to find mass but in terms of milligrams. So let's first find mass in grams. So we know that we've said our mass is just equals to density times volume. Okay, like from the previous questions we're from solving. So in this case, what are we going to do? We have our density to be 2.16 grams per ml multiplied by what is our volume is 2 mils. So the mil and the mil are going to cancel. Okay, when you multiply that, it's just giving me 4.32 grams. Now we found our answer in grams, so therefore our job would be now to convert these grams to milligrams. Okay, now you know that 1 gram milli just means 10 to the power 3, right? So in this case it's going to be 1000 milligrams. Okay, and this, if this is our conversion unit, our gram and our gram are going to cancel, and when we multiply, therefore our final answer in terms of milligrams is going to be 4320 milligrams. So that will be our final answer. Question number 8, we are told what is the density in grams per ml of a substance that masses 0.987 kg and has a volume of 4.52 times 10 to the power 2 mils. Okay, so we're trying to find the density, and density, we know that density is equals to mass over volume. Okay, so we'll go along with it. So we've been given our mass to be 0.987 kg. Okay, so we're trying to find the density in this case. And the density that we want to find it in which units? Let me write the units. We want to find it in terms of grams per ml. Okay, so because this one is in kg in terms of mass, we're going to convert it to grams, right? Okay, so how are we going to do this one? So we're going to multiply by the conversion unit. Okay, and we said 1 kg is just equals to 1000 grams, right? Okay, so if that is our conversion unit, let's come down. What is our volume? The volume we've been given that it is 4.52 times 10 to the power 2 mils. Okay, and okay, so since it's already in mils, there's nothing much we're going to do about the volume. Okay, because it's already in mils. So when we solve what is on top, the 1 kg and the kg can divide. Then we're going to multiply what is on top. So on top, when the 0, when 1000 multiplies by this, it just means the point is going to move. So what am I going to have? I'm just going to have 987 grams on top divided by 4.52 times 10 to the power 2 mils. Okay, now that our units are in the right measurement that they want, we're just going to divide. And when we divide, I'm finding 2.18 grams per mil. So this will be our answer. Now question number 9, we are asked how many degrees Celsius are in 315 kelvins, then degrees Fahrenheit are in that, and kelvins are in those. Okay, so let's start with the first question. So we're trying to to convert from degrees to Celsius. from degrees Celsius to Kelvins, or from degrees Fahrenheit to Celsius, whichever way. So let's start with the first question. Okay, so you know that when you're converting from Kelvin to degrees Celsius, you subtract 273.15. okay, that is if you are converting to Celsius, because that is a conversion unit. That is a conversion unit. Now, okay, for the Fahrenheit, we don't do it. Let's first solve the first question. So what are we going to have? We have 315 kelvins. So now we're trying to convert it to degrees Celsius. So you always subtract 273, because that is 1 degree Celsius is goes to that 273. So when we subtract, what are we going to get in terms of Celsius? We're going to have 41.85 degrees Celsius. So this would be our answer for A. Let's come to B. Now to B, we are told to convert degrees Fahrenheit in 30 degrees Celsius. Okay, so we're converting from degrees Celsius to Fahrenheit, okay, to degrees Fahrenheit. So now what you do for the degrees Fahrenheit, you are going to get your Celsius temperature, you're going to multiply it by 1.8, then after you find your answer, that answer you add a 32. So this is the conversion unit. So what are we going to do? We've been given 30 degrees Celsius. So this 30 degrees Celsius, we're going to multiply by 1.8, and from after that we're just going to add a 32. And when we do that, on my end I'm getting 86.0 degrees Fahrenheit. So that is a conversion unit. Then the last one, kelvins are in negative 15 degrees Celsius. How many kelvins are in negative 15 degrees Celsius? So what are we now? It has changed. This one we're converting from kelvins to degrees Celsius. Okay, now we are converting from degrees Celsius, we're going now to Kelvin. Okay, so because we're going to Kelvin, we're going to now subtract. Okay, we're going to subtract the 273 like we did. So we're going to get our negative, we're going to add, okay, negative 15.5 degrees, okay, Celsius. Because we're going to Kelvin, we're going to add, okay, 273, okay, 0.15. Then when you do that, when you add these two, well, I'm getting 257.65 kelvins. So that is our final answer. So just know these conversion units, then you are good to go. Okay, let's solve question number 10. Now we are asked that the human brain is located in the upper portion of the head. We know that, with a volume that will be approximated by a cube. Oh, okay. A cube is equals to 20 centimeters on a side. Brain cells consisting of 10% neurons and 90% glia vary in size, with dimensions ranging from a few microns to a meter or so. Taking D is equals to 10 microns as a typical dimension, and consider a cell to be a cube with each side having that length. Estimate the number of brain cells in the human brain. Okay, now this is very interesting. Allow me to come up with a cube. Okay, let's say this is our cube. We're saying this is our cube. Okay, we're not artists. Let's say this is our cube. Okay. Then we have also been told consider few micrometers. So taking d microns as a typical, consider a cell to be a cube with each side. Okay. So also considering the brain. This is like the brain that we've drawn, but now also considering a cell again to be also a cube. So let's also draw a cube for a cell. Let's say this is our cell, quite small because it's just a part of that brain, the one we're talking about. So let's say this is also our cube. Okay, now we've got this. So the human brain, let's say this is the brain. Okay, then we've been told that it is located in the upper portion of the body with a volume that could be approximated by a cube of 20 centimeters on each side. So because it's a cube, it's going to have the the length, the width, the breadth. So let's say because they told us 20 centimeters on each side, so all the all the sides are going to be 20 centimeters. So on 20 centimeters, 20 centimeters, and the height also to be 20 centimeters. That is the brain. So we are saying this is the volume. Okay, since that is the volume, we can find it in advance. So the volume for the brain, for the human brain, is just going to be, that it is, you're just going to because it's the same unit, I'm just going to say L to L to the power L cubed. Okay, that would be the volume. So the volume in this case, we're supposed to multiply everything. So we're going to multiply 20 centimeters times 20 centimeters times 20 centimeters. So 20 times 20 times 20, all these ones are in centimeters. So what are we going to get? Okay, so when we multiply those ones, they're just going to give me 20 multiplied by 20, that is like 400. The 400 multiplied by 20, that is like 8,000. Okay, 8,000 centimeter cubed. So this is the volume of the brain. Okay, now what about it? They are saying ranging from a few very in size, taking dimension, having an estimated number of the brain cells in the human brain. Okay, a typical dimension. Okay, so now this is a typical brain cell. This one, typical brain cell. Okay, so it's found in that brain. So now what are the units? They're saying D to be 10 meters, 10 microns as a typical dimension to consider. Okay, so they've given us 10, D to represent 10 microns. So this will be 10, this will be 10, and the height will also be 10. So to find as the volume of the brain of the cell, so our D3 will just be equals to, we're going to get our 10. Okay, this is 10 microns like they've said, but now since there are 3 of them, I'm going to square them like that. So what am I going to have? I'm going to have my the volume of this cell to be 10 1000 microns cubed. Okay, so now that we've got that, the question is asking us to estimate the number of brain cells in the human brain. Okay, so this is very straightforward now, because we have the volume of the human brain cell, and we have the magnitude of the volume of one cell in that brain. So we're just going to divide. So therefore, what do we write? Okay, so allow me to rub this part. So therefore now the number of brain cells of brain cells to just be now equals to the volume of the human brain, which we've already found it is 80,000 centimeter cubed, divided by the volume of a typical brain cell, which we've also found to be 1000 microns. this is cubed. Okay, then when we divide that, it just gives us 10 times 10 to the power h times 10 to the power 15. So this will be like the number of brain cells in that human brain. Okay, so quite a big number of these cells. Question number 11, we are told saying that the average heart rate of an adult is 80 beats per minute. Okay, so we're saying 80 beats per minute. How many heartbeats will one's lifespan of 70 years contain? Okay, if this is minute, 70 years. Okay, so this is very, very interesting. So we're supposed to convert our minutes to years. Okay, so what do we do? Okay, so let's just do that. So we've got 70 years. We're supposed to convert this to minutes. Okay, so let's do that now. Let's start with the year. We have years here, right? So if you want to cancel years, 1 year, how many days are in 1 year? We know that it's 365. But if you consider, let's say, the leap years for each year, or for accounting for leap years, you're going to have 365.25 days. Okay, a leap year is where you have an excess number of days, maybe like 366 days. Okay, so considering also those ones, we're going to have that. So now we're saying these are days. Let me just write days to avoid, so that we follow it nicely. Multiplied by, now 1 day, we know that 1 day is just equals to 24 hours, right? Okay, now let's convert the hours. We know that 1 hour is equals to 60 minutes. Okay, we're not going to go to seconds. We can even end here, because we want our answer to be in beats per minute. Okay, how many beats will be? Okay, so that is the thing. So what do we do? So I can cancel the hour and the hour. I can cancel the day and the day. Okay, the year and the year. Now I've remained with minutes. Okay, so what do we do? We're just multiplying what is on top. Now when I multiply what is on top, on my end I'm getting 369. No, it's 36792 3,300 actually minutes. So this is in minutes. Okay, now that we've got in minutes, even easier, we've been told that the average heart rate of an adult is 80 beats per minute. Okay, now if we're now to convert this one to beats, because they're asking us how many beats one's life. So the 1 beat, so it means we have to convert this to beats. So what are we going to do? We're just going to multiply by what we are just found. We're just from finding 36792 300 minutes. So the minute and the minute can divide. So our job is just going to be now to multiply 80 multiplied by this number. So what are we going to get? On my end, I'm getting like this is a big number, so I'm going to say it's 2943. Okay, then there is 384 1000 bits. Okay, how many zeros? 1 2 3. So this is like 2.9 2.94 billion bits. Now that's a B. This is just the same as 2.9 billion bits. This is a B in a 70-year lifespan. So you'd have, the heart would have beat, it would have like pulsed about that much. Oh, that's a big number. Let's go to question number 12. Now question number 12, we're saying Muiza wants to determine her heart rate. She counts 7 pulses in 7 seconds. What is her heart rate in beats per minute? Okay, so we are saying pulses per second. Then want to change from to beats per minute. Okay, so that it becomes easier for us. But now we've been given that this Muiza wants to determine how she counts 7 pulses. So pulses are 7 in 6 seconds. So we have to first find the pulse in seconds, pulse per seconds. And when we divide that, 7 divided by 6 is 1.17 pulse per second. Okay, now that we've got this, we have now everything that we need. So we have 1.17 pulse per second. This is multiplying by, now you know that in terms of seconds, you know that 60 seconds is equals to how many minutes? 1 minute. Okay, so that is our conversion unit. So a pulse is just the same as a beat. Okay, so nothing much, there's nothing like we convert to beats. Okay, it's the same thing, pulse and the beat is just the same. So we'll say the 1 second and the second and the seconds are going to divide. Therefore our final answer to just be 1.17 multiplied by 60 on top. I'm getting 70 pulse. There's a minute down, so per minute. Okay, or if you want, you are going to rate it, this is pulse per minute, but they want your heart rate in beats per minute. This is just the same as 70 beats per minute. So that's how you're going to solve this one. Now number 13, we are asked to say, we are saying a label of a certain medication is showing 60 to 200 milligrams per kg per day max. An MD or a medical doctor prescribes 400 micrograms of paracetamol to be taken by an 8 kg infant every 4 hours. Is the doctor's prescription within normal range? Okay, so the daily dosage we're saying of medication for this 8 kg infant, okay, we're saying what is it going to be? So okay, so an 8 kg infant every 4 hours. Okay, so now every 4 hours, so in a day, we're talking about the daily. How much are we supposed to give in a day if this child is taking every 4 hours? So you know that in a day there are 24 hours, right? Every 4 hours we are giving this dosage to this child every 4 hours. So we have to first find that. So it means 24 divided by 4, that is like a 6. So this child is supposed to take 6 times in a day. Okay, so now we are prescribing, we're saying an MD prescribes 400 milligrams of paracetamol to be taken by this child every 4 hours. So how much in a day is this child going to take? So we're going to multiply this 400 grams that we're giving this child. Since we're giving this child or this infant 6 times, so what are we going to get? We're going to get in a day is supposed to take 2400 milligrams. Okay, yeah, 400 multiplied by 6, that is the total daily dosage that this child is supposed to take. Now the dosage in mkg, they're saying the dosage in milligrams per kg per day. So what is it going to be? Okay, so what is it going to be? So we're going to get our 24,000 or 2400, this. Okay, want to convert to kg per day. We already have our answer in milligrams, which is 2400 milligrams. First, to convert to kg, we're saying this baby or this infant is 8 kg. So we're going to write our 8 kg here because we're talking about 8 kg infant. Okay, and this is a daily dosage. The 2400 is a daily dosage. So this is per day, right? Per day are given that. So that's what it means. So we're going to now divide 2400 divided by 8 kg. That just gives me 24 divided by 8. That is like 3. Okay, 300 milligrams per kg per day. Okay, now look at the range. A label of a certain medicine is showing that to that per day max. An MD prescribes that. Now, is the doctor's prescription within normal range? Okay, so is it really within normal range? It's not really within. Actually, this is higher, right? 300 milligrams per day per kg. So it's not within. Normal range, because the range is from 60 to 200. So that is our answer. Now let's solve the last question. They are saying you want to give 50 milligrams per kg of Fortas to a child who weighs 20 kg. The medicine is available in oral suspension, labeled 100 milligrams per meal. How many meals should be administered? Okay, how many meals should be administered? Okay, so let's first find the total dosage. You want to give this to a child who weighs that. The medicine is available. How much meals should be administered? Okay, so you want to give 50 milligrams. So the prescription that you want to, because it's a prescription, this prescription amount, it is 50 milligrams per kg. Okay, for TAS, right? Now what is the weight of this child? The weight of the child, we're told this child weighs 20 kg. Okay, so now for us to now find what is supposed to get the total daily dosage for that day. Okay, so it means this is 20 kg and we want to find the dosage in terms of grams. Okay, so what are we going to do? So 50 milligrams multiplied by 20 kg. And when we do that, what do we get? We're going to get 100 milligrams, because this is 50 milligrams per kg. So the kg and the kg, they're going to divide. Okay, we're just going to have the one that's supposed to administer to be 1000 milligrams. Okay, to this child who weighs 20 kg. Now I want to find they are saying that an oral suspension label is 100 milligrams per meal. Okay, now we found our milligrams. Okay, but now want to convert it to meals. Okay, we already have the one in meals. So what are we going to do? We're supposed to convert to milliliters. So what is going to happen? So we already have 1000 milligrams. So we're going to divide. They were supposed to divide this by the oral suspension that we've been given, which is 100 milligrams per meal. So we are dividing this expression by 100 milligrams per mil. Now when you divide that, what are we going to get? We're going to have 1000 milligrams multiplied by 1 mil over 100 milligrams. Okay, now we have everything that we need, because the milligram and the milligram, they are going to divide. Okay, now in terms of mils, because you're asked how many mils should be administered, so I want our answer to be in mils. That's why our target there is living in the mils. So what do? We cancel 2 zeros, we cancel 2 zeros. So our final answer therefore is going to be 10 mils. So this is how we solve these questions on tutorial sheet 1. So see you in the next session, and don't forget to subscribe.